we take the second question on the principle of moments. Now, look at this. A fishing rod AB is shown in the figure below. The figure is not to scale. End A of the rod rests on the ground and a string is attached to the other end B. A support stick exerts a force perpendicular to the rod at point C. A support stick at point C. So this is perpendicular to the rod. Very important. At point C. The weight of the rod acts at point D. So that's point D. The tension T in the string is in the perpendicular direction to the rod. The rod is in equilibrium and inclined at an angle of 56 degrees to the vertical. The forces and the distances along the rod of point A, B, C, and D are shown in the figure. First question, show that the component of the weight that is perpendicular to the rod is 4.3. This is the weight of the rod. So we want to find the component of the weight acting perpendicularly to the rod. Let's label it like this. Is that okay? Then we have this. Of course, you should know that this side here, this is definitely your hypotenuse. Okay? So if you want to find this side now, you see that the component of the weight of the rod that is acting perpendicularly to the rod, it will be acting in a direction that is opposite to this angle. How do I know that? If I draw this like this, you know, this is a parallelogram now. Opposite sides of a parallelogram are equal and parallel. So if you cannot see it, if that is not obvious to you, it should be obvious to you now. So this direction, let's call it Y, is acting perpendicularly to the pivot, and it is in a direction that is opposite to this angle. So the hypotenuse is the weight if you look at your right angle triangle. So what trig ratio should be used there? It should be sine theta. So you have sine 56 is equal to the component of the weight of the rod perpendicular to the pivot. So that is W with that perpendicular sign over the weight, which is what? 5.2. So the component of the weight of the rod at perpendicular to the pivot will be 5.2 times sine 56. If you do that with your calculator, you don't waste much time. You just write your answer. That will definitely give you. You use your, that will be sine 56 times 5.2. So 5.2 times sine 56. When you do that, it's going to give you 4.311 newtons, which is approximately to 2 subsequent figure 4.3 newtons. So the next one says, by taking moment about end A of the rod. So the important thing now is that all the forces are not made to act perpendicularly to the distance from the pivot. So this is the most recent one we found now, which has a value. Don't forget that we are acting vertically downwards because the weight is acting vertically downwards. So the component of the weight in this direction is acting vertically downwards. It's acting perpendicularly downwards to the rod, and that is 4.31 or 4.3 as the case may be. So all these forces are acting perpendicularly to the pivot. by taking moment about NA, this is a downward force. It's going to cause the bar to turn in this direction, which will be anti-clockwise. This is acting upward. It's going to cause the bar to turn. It's acting upward. It's going to cause the bar to turn clockwise. So you can see it. It's going to cause the bar to turn clockwise. This acting downwards is going to cause the bar to turn anti-clockwise. So we have the total clockwise moment is equal to total anti-clockwise. So we have the total is equal to total anti-clockwise moments. So don't forget that moment is the product of the force and the perpendicular distance from the pivot. So the clockwise moment that you have there is 4.6 newtons force. Its perpendicular distance from the pivot will be 0.60 plus 1.2. That will give you 1.8. Is equal to the total anti-clockwise moment, which will be T times its perpendicular distance from the pivot. Can you see it? We are taking the moment about NA of the rod. So it will be the product of the force and its perpendicular distance from NA, which is 0.6 plus 0.6, 1.2, 1.2 plus 1.2, 1.4. Plus the other anti-clockwise moment is the component of the weight acting perpendicularly to the distance from the pivot. And that will give you what? 4.3 times 1.2. So we have written out the equation. You bring out your calculator, then you allow the calculator to do its work quickly. So that will give you 4.6 times 1.8. Don't forget that. That becomes 8.28. Is equal to 1.40 plus 4.3 times 1.2. If you do that, that will give you 5.16. So I can say that 1.40 is equal to 8.28 minus 5.16. 8.28 minus 5.16. So you do that minus 8.28. So I have 1.40. Subtract it from this is going to give you 3.12. So that T becomes what? 3.12 over 1.4. And that will be give you 2.23 newtons, which is approximately 2.2 newtons if you round it up to two signal figures. Why is it appropriate to round it up to two significant figures here? Because the constituent readings, they are in two signal figures. So when there's a need for you to round it up to the same number of signal figures as any of its readings or any of its values that is having the lowest significant figure, which in this case is 2. So that is 2.2 newtons. So you can see that the same principle has been applied here once more. We identify the clockwise moment and anti-clockwise moment, and we identify their distance. We take the moment about a point in order to solve for the problem. So you see that you are solving for force or you are solving for distance.